Hello everyone, welcome and thank you again for attending today's webinar, much appreciated. So I'll start with a very brief introduction to myself. I'm Stephen Davis. I've been with SKF now 13 years as an application engineer. I came straight out of university, having studied as a mechanical engineer, and since then I've been working with SKF's UK original equipment manufacturers and end users and authorised distributors for the majority of the industrial segments we support. Having worked with them, it's clear one of the challenges we see the design engineers face is the pressure of having to design a robust yet cost-efficient machine. And at the centre of most of these machines are the bearings. Therefore, in order to do this, they need to know exactly how the bearing arrangement will perform. And this is where the SKF's options of online calculation tools can help, allowing them to quickly evaluate the design of the bearings and their field performance based on relevant application requirements and operating conditions, so they can reach an optimum design performance early on in the development. So in this session, I'd like to take you through some of those calculation tools SKF have available for you. Along the top, we've got Bearing Select, Simpro Quick and Simpro Spindle. Unfortunately, we haven't got time to go through each of these in detail, so I'll be showing you a worked example of Bearing Select, which is the simplest and quickest tool to be used for bearing selection, both for the rolling element and plain bearings. And I'll give an overview of the capabilities of Simpro Quick and Simpro Spindle, which offer a more advanced assessment of rolling element bearings. We have had a dedicated webinar on Simpro Quick going through a worked example. Although it's past, there is a recorded version available to watch at any time. So I'd recommend seeing that in parallel if you haven't already, and we can of course advise where to go to get that from. In addition to the bearing rating life, there are also other key factors that should be considered when putting together the bearing specifications for an application, and lubrication is of course one of them. So I wanted to also highlight and go through the two at the bottom, Lube Select and Dial Set, which are used for selecting the most appropriate grease for the operating conditions, but also helping you to determine a suitable lubrication regime with regards to quantity and frequency of grease. So first of all, where to go to get the tools. Hopefully this will work. If you click the link, it'll take you through to the SKF homepage, which hopefully you should all be seeing now. And once you're there, you go to support and then go to engineering tools. You'll be greeted with all the tools available to you. There's a long list with a number of pages there. So I'd recommend just using the filter function to be able to categorize them into particular platforms. So for the ones that we're interested in today, Bearing Select, Simpro Quick and Spindle, and then the lubrication ones, we can filter it to bearings and units, and then also for lubrication solutions. We'll start with Bearing Select, filter. You'll see it come through. We've got Bearing Select there, but we've also got Simpro Spindle and also Simpro Quick to take you through to the home pages of them. If we go to Bearing Select, you'll be greeted with the home page for Bearing Select. You may, if you've not already visited this site or this tool before, be asked to register. It's free to do so. You just need to enter in some details and then you'll be granted access straight away. So if you haven't done that already, then you'll need to. But once you have, you'll be able to click on open up the tool and you'll be greeted with the front page. So here you get to make your first selection of whether you're looking at doing a selection based on a plain bearing or on a rolling element bearing. With the plain bearing, this will calculate the basic rating life and frictional moment for spherical plain bearings, rod ends and bushes based on some simple operating conditions. Whereas there's a few more features for the rolling element bearings. Along with rating life, it will also give you grease life and relubrication intervals, lubrication conditions, bearing loads, friction and power loss, and bearing defect frequencies and adjusted reference speed. So there's a little bit more behind the rolling element side plain bearings is catching up a little bit, and there'll be some developments on that time comes. Also, just point out in terms of languages, we've got currently English, German, and Chinese and Spanish, but I believe that Italian, not Spanish, sorry, Chinese and Japanese, but I believe that Italian and Spanish will be joining in the next few weeks. If we go into rolling bearings, which is the one I wanted to show you an example on today, click that. We go through and we can pick whether we want to be doing a selection based on a single bearing or 2 bearings on a shaft. I'd like today just to show you through the 2 bearings one. This one's more helpful. So to start with, you get to choose which bearings you're looking at using. You can do this in 2 ways. If you don't know the bearing designation to start with, you can search using the drop down by the bearing type, and then you can start entering your shaft diameter. But also there's additional filter function where you can search also by bearing outer diameter and bearing width as well. But if you happen to know your bearing designation, you can type that in. I'm going to pick a sealed for life deep groove bearing 6210, and that's pulled that one up. I'm going to select that one. Just to point out the legends at the bottom here, it is what I'd recommend worth picking is certainly a popular item. So anything marked with a black little triangle tells you that it's a popular item, and therefore availability should be good. The last thing you want to do is go down too far in the design route, selecting a bearing only to find that it's on a long lead time or not always available as readily as others. So try to pick one that's a popular item. And also anyone that is coloured blue is from our SKF Explorer range. Once you've picked that, you've got the option to then pick the right-hand bearing if it's asymmetric design. If it's the same, if it's a symmetrical design and it's same bearing at both ends, you click and it'll just copy that one across, and it confirms your selection down here. And we've got 2, 6, 2, 10 sealed bearings. So once you've picked your bearings, you move across and you start to build up your system. So the first thing it asks is which one's going to be the located bearing. You can choose left, right, depending on the bearing arrangement or the application. It might be a situation where neither bearing is going to be located, so there's no actual loads are ignored. But however, I'll leave it as a default for the moment that the left bearing will become the located bearing. You can then choose your shaft orientation, horizontal, vertical, and also whether it's going to be inner ring or outer ring rotation. Default is inner ring. It's simply a case of clicking to change it to outer ring rotation and clicking back to revert to inner ring. We'll choose our bearing span. So for my example, 200 millimeters. And then we can start inputting our bearing loads. So we can do this either in the Cartesian coordinate system or in our polar coordinate system, just simply by toggling between these 2 selection points here. And you can also add up to 5 external loads by simply just clicking on the plus and then easily just removing them if you need to. Again, for my example, I'm just going to build up an imaginary helical gear. So we've got a PCD of 120 mil, often at a radius of 60 millimeters. The gear is going to be positioned in the middle of the 2 bearings, so positioned at 100 mil, and we'll have tangential force of 3.2 kilonewtons, separating force of 1.6, and an axial 0.6. Now entering our speed. And what you can also do if you want to is you can add load cases. So you can add in up to 5 load cases, and then you assign the weighting for each of those load cases here. And simply remove them with the cross if you need to. Once we've entered in our bearing loads and rotational speed, we then define what our operating temperature is. Default throws in the inner ring at 70 and outer ring at 65. And it assumes that it's for both left and right bearing, but you can tailor it to each bearing just by unticking this. this. Obviously, if you've got specific operating temperatures known to you, then you can enter them in. Equally, SKF does have an internal software where we can enter in your application and operating conditions, and we can start to estimate based on some generalized heat and cooling functions of the shaft and the housing what we think the operating temperature would be. So we can assist with that if need be. And for this example, I'll leave it as the default. We then click calculate, and just as a check, you can now visually see where it's applied the load. We've got axial and 2 radials centered in between the 2 bearings. So it's just a little visual check there to make sure your loads look to be in the right position. And it also shows that the right hand bearing is going to be the one taking just radial load, and the left hand bearing being located is going to take both the axial and the radial load. We now look to define the operating conditions, the lubrication, the contamination, and the clearance in the bearing. So we can click down here and edit default settings. As I've picked a sealed for life bearing, it comes with a predetermined factory fill. So this has been brought in by the software. There are other grease options available as part of that product selection. If you picked an open bearing or an unsealed bearing, then you would at that point have the option of defining whether it's an oil lubricated bearing or whether it is still grease lubricated, and you'd start to put in your lubricant details, i.e. viscosity for that specific lubricant. You define cleanliness. You've got a drop down menu for normal cleanliness, high cleanliness, severe contamination, and more information on the specifics behind those contamination levels can be found by clicking on the cleanliness link, which takes you to the website for further information. For a sealed bearing, I'd expect it to be normal cleanliness, if not towards the high cleanliness. You can keep this one selected, and it'll assume again that these operating conditions are for the right hand bearing as well as the left, or again, depending on the arrangement, if one side is, chances are, more contaminated than the other, you can differentiate the two. Go through to radial clearance, and you've got the option of choosing other than a normal clearance bearing. Again, through C3 or C4 options for this particular bearing. Other options might be available depending on the bearing that you've selected. Just for argument's sake, picking a C3. We do that for both bearings, and then we click OK. So we've set our bearing loads, our speed, our operating conditions. We'll just run through calculate one more time, and that's our model built. And we're now getting out the calculation results at the bottom of the page. So if I just expand all of these, you can see the first one is just bearing properties. It's just giving you an overview of the bearing that's been selected, its dimensions, its load carrying capacity, and its speed rating. And then we get down to the first calculated results. So the first one shown is minimum load. So we can see here if the minimum load requirement's met, and therefore we can try and ensure that we're avoiding the chance of skidding taking place. And in this instance here, minimum load is 0.19 kilonewtons, which based on the bearing loads, that's met. Also shows the viscosity rating. Here we like to try and aim for a viscosity ratio of between 2 to 4 to ensure we get full film separation at the rolling contact, and therefore most ideal lubrication conditions. For this particular example, based on the speed, bearing size, lubricant viscosity, and the operating temperature, we've got a viscosity ratio of about 2.8. So that's looking good for this example. Of course, if it was showing less than ideal, then you could start to go back and reselect a lubricant that would start to give you better conditions. Gives you your bearing reaction loads, which it equates to equivalent dynamic load that you can compare directly against the dynamic load carrying capacity of the bearing, which gives you the C/P ratio. And that's quite a quick way of looking at a bearing and sort of assessing quite quickly whether it's heavily loaded or lightly loaded. Normally anything with a C/P of greater than 15 is sort of a light load. not considered too arduous on the bearings. Across, we've got grease life and relubrication interval. As it's a sealed for life bearing, you haven't got the ability to relubricate in this instance, so in fact it's giving you a grease life based on an L10, in line with the basic rating life L10 of the bearing. In this instance, it's coming out at 24,000 hours. Also gives you the results for the static safety factor, so you can ensure that you're not causing any indentation in the bearing. As a general rule of thumb, anything with a safety factor of greater than 3 should therefore avoid any indentation. So in this instance, we're well above, so we've got no worries of indentation in the bearings in this example. Then over, we've got the bearing rating life, which gives it in terms of the ISO 281, the basic rating life, the L10, which is based on purely load, capacity and bearing speed. And then we've also got the SKF rating life, which now starts to look at the effects of lubrication, contamination and material fatigue load limits as an impact on the life. And this can be both positive and negative compared to the basic rating life, depending on what those operating conditions come out like. In this instance, we had favourable lubrication conditions, a relatively clean environment, and the loads were quite light. So in fact, we find that the SKF rating life suggests that calculated life should be more favourable than the basic rating life. But of course, we should also consider that as it's sealed for life bearing, we did have a grease life of only 24,000 hours. So in fact, for this particular bearing, the service life is going to be limited by the grease as opposed to the actual rolling element fatigue. So it's just something to bear in mind that other factors start to influence the bearing service life other than just fatigue. Some of the other outputs, you've got your frequencies, your rotational frequency and your bearing defect frequency, also known as over-rolling frequency. This is something for the condition monitoring engineers to compare against their data analysis to see if there's any signs that there might be premature bearing failure taking place. And finally, if it's of interest, then it also gives you the option to calculate your power loss, so you can see look what particular sources of friction are influencing it more, whether it be to do with the load affecting rolling element, sliding and seals, or if in the case of an oil lubrication and oil bath, you'd expect to see some drag losses associated. So once you've calculated that, you can move across and you can now start to look at the effect of what fits that you want to use on the shaft or in the housing. You've got two options. You can either have the fit recommendation turned off and you choose the housing fit and the shaft fit, and then it will tell you the tolerance and what the probable interference and clearance fits are for those chosen tolerances. Or you can turn the fit recommendation on and it will start to give you a recommended fit based on the operating conditions that you've entered in. These are predominantly a function of the bearing type, size and the applied load, and the operating conditions in terms of how that load is rotating or stationary relative to the rotating ring. So it asks you here, is the load direction rotating with the rotating ring or if it's constant in direction? For our example with the gear, we'd expect the load to be constant in direction. And it also asks whether we're going to need to consider thermal expansion. Depending on your bearing arrangement, some bearings require to accommodate thermal expansion by sliding on the bearing seat. For example, a deep groove bearing would need to slide in the housing to accommodate thermal expansion of the shaft. Other bearing types, such as cylindrical roller bearings or carbs, they can accommodate that within the geometry of the bearing, so they don't necessarily need to be able to slide in the housing. So if you've got one of them, you can keep that off, but in our instance with the deep groove, then we need to make sure that can slide. So we turn that on. And then here it provides the recommended tolerance classes and the fits for the bearings. We've got a shaft, J6 and K5 for the left and right. And then in the housing, we've got H8 and G7. And G7 is a slightly larger clearance to allow that right-hand bearing to slide as it's a non-located. Again, it defines the tolerances and then the probable interference, fits or clearance that you'll have as a result of those fits. So finally, you just get the last summary page, which just gives you an overview of some of the key calculated parameters. And then you have the option of saving that. And like I say, if you've logged in, you can save this and then you can log back in at another date and retrieve this report if you need to go back and review it, edit it, or you have the option of printing it off either as a PDF or I think a Word document as well. So hopefully that gives you an overview of bearing select, which you can build on by going away and running through some examples yourself. What I'd like to do now is just move on to Lube select. Go back to engineering tools. We filter for lubrication solutions. And we'll come through and find we've got Lube select and dial set. So if we click on Lube select, again, if you've not registered, you'll need to do so. But if you've done it already once for bearing select, then you don't need to do it again for the other tools. So once you can go in, you're greeted with the home page. So basically, Lube select does what it says in the name. It helps you select an appropriate lubricant for a particular application. You can do this in two ways. You can choose by application conditions, which if you fill these in, an analysis is made based on generalized selection rules SKF has developed from experience over the years. And the suggested greases will be a weighed compromise to fill the described application conditions as well as possible. Or you can choose to select based on the application profile, in which case you'll pick one that best matches your own application. The profiles give a best practice suggestion, again, based on SKF's years of experience. So, for example, if we go into application profile, you'll see we've got a number of different industries: automotive, drives, got heavy industries such as metal, pulp and paper, and within them, a number of examples of application. So if you happen to pick on one, it will come up with a typical example of the application profile, telling you the sort of type and size of bearing used in that particular application, and what the sort of operating conditions are for temperature, speed and load. In terms of the low, medium, high range, I'll actually show you later on in dial set how you can actually equate these to exact values. You can actually categorize which level you fall into. It also just gives you some relevant properties that the lubricants need to offer for this sort of application. So in this instance, we've got water resistance and rust protection. And then at the bottom, it gives you the typical lubricant that's used for these sort of applications that you can go away and start looking at in more detail to make sure it's suitable for your particular application. If you want to do it based on application conditions, you click Start. And here's just a quick list of the lubricants that will be made a selection from out of the software. Close Start. Yeah. Now starts for you to add in your operating conditions for your particular application. So you can do it either, again, start by choosing your bearing. You can do this either by searching by designation. Again, I'll use the same example as bearing select. Or if you don't know the bearing designation, you can choose based on the bearing type, and you can fill in the boundary dimensions for that bearing. There's a little bit just here for specific for spherical roller bearings and cylindrical roller bearings, as the axial to radial load ratio has an impact on the grease selection for sphericals. So you just need to pick here whether that situation is met. And also for the cylindrical, if you've chosen that, you just need to define whether it's a non-located or a located bearing, as again, that will have an influence. You can then start to put in your operating conditions. Start with typical operating temperature. Minimum startup if it's known. Not a mandatory field to fill in. Same with the maximum peak, not mandatory, but obviously the more information you can fill in, the better the selection. We can put in rotational speed. We have to then choose our load ratio, which you can pull from bearing select. So in previous situation, we had a CFP of about 18 or 19, so we'd fall into the low class. Define whether we expect any shock loads, and then also what the ambient temperature is going to be. So we then have the option at the bottom to add in some additional conditions that are relevant to the application. If shaft orientation might be vertical or horizontal, whether it's perhaps oscillating application rather than rotating, and if it's an outer ring rotation. You can also choose how relevant some of these properties are. So we might find that the application requires high rust protection as important, low noise relevant but not essential, but we do want a very long grease life is important. So once we've entered in that, we just click start. And you'll be given a list of appropriate greases that the program selected from that original set list. Greases that are marked green are in principle appropriate. Greases that are marked red are not, and that warnings are given. More information on this can be found at the grease rating. And you can see now it actually splits out into the particular operating conditions. So we had temperature, speed and load, but also some of the critical ones that we selected. And the rating 0 to 100% shows you how well the greases are performing for those relevant operating conditions. In this particular instance, HP2, WA2 and HB2 have shown as overall to be the best. You see that perhaps there are other greases, for example ET2, that might give you a better long life, but don't perform as well in some of the other key areas. So overall rating isn't as high as the others. By clicking on the greases, you can get more information on them. It gives you the viscosity ratios at various temperatures. It gives you some information on how to re-grease and re-lubricate. And also at the bottom, there's information on the actual properties of the lubricant, thickness type, base oil, consistency. You've also got the option to click on compatibility and see how that grease would perhaps compare with a grease that may be already in situ, to see whether it can be simply purged out or whether it's got to be cleaned thoroughly before the new grease can be put in. If you just click back on results, then you've got the option of clicking a report, and again it'll put it out in a report function for you to take away and put in your records. What I should just say with Lube Select, it's important to state that the lubricant selections made are based on generalized selection rules. It cannot take into account every detail of the application, and the selection is made from a limited set of greases. It's therefore still always the responsibility of the user to validate the suitability of the lubricant selection. You need to treat this tool with some common sense. The calculated values should be used as a starting point and not as an exact science. The values should really be reevaluated based on experience and inspection of the grease once in service, and changed if necessary. So that's just a brief summary of Lube Select. We now just go back through, find dial select. You get through to the home page for dial set. This is available for Android and Apple devices. I think it only has a choice of English on the app version. However, you can download it as a standalone program onto your desktop, in which case then you've got a number of languages available to you. I would say it's designed to help you set up an automatic lubricator. You enter in the operating conditions, and select the grease appropriate for your application, and then the program provides the correct settings for the lubricator. But what it also provides is a quick and simple tool for relubrication intervals and quantity calculations, which can be adopted when manual greasing is in place. And for me personally, this is what I use it for, more so than the actual automatic lubrication settings. So once we open it up, we get the home page where we start to put in the operating conditions. First of all, we choose the bearing. I have to admit, my one criticism, if I should say, for this is that rather than choosing the bearing by designation, you have to search by bearing or choose bearing type and fill in the bearing dimensions. So for my example of the 6210, we've got a deep groove ball bearing as our bearing type, dimensions, 50mm ball, 80, 20mm wide. We now can choose the lubricator if we're looking at using it for automatic lubricator selection. If you're using it just for manual greasing, then you can ignore this and just leave it as the defaults. I'd recommend starting first of all just leaving it with the grease as unspecified. This is assuming a lithium soap mineral oil, and this also acts as a little mini grease selection function as well, because what you'll find is you'll see to start with a number of greases are grayed out and some you can select. As you enter in the operating conditions, they will change to suit the operating conditions that you're putting in. So to start with, I'd say leave that as unspecified and start to put in your operating conditions. Speed, number of operating hours per day, if it's not 24/7, what your bearing operating temperature is, just for the time being, leave it as normal. It's between 63 and 78 degrees. You then start to define your contamination and moisture levels. So put it as low, as it was a sealed arrangement. Load condition, you can choose from low, moderate, high. Again, I'll show you in a little bit how you actually categorize these into defined values to associate to them. Okay. Do you have any shock load? What the ambient temperature is? Shaft orientation. Default's always to vertical, so it should just always make sure if it's a horizontal arrangement that you do click that, because it does have a big influence on the grease rate, grease life. Replenishment from the side, that's specific to spherical roller bearings. Spherical roller bearings have what we call a W33 groove in the outer ring, which allows you to grease directly into the contact. So it's a more efficient way of getting grease into the bearing. So you don't necessarily need to use as much grease. For other bearing types, you're always going to be lubricating from the side. So for the deep groove ball bearing, it's grayed out, and that's the only option from the side. And then the final choice is, again, if it's inner ring or outer ring rotation. So for our example, we'll leave it as no for outer ring rotation. Gives you the results. So the first result is the relubrication interval based on some idealized operating conditions. It assumes lithium soap grease with mineral oil. It assumes operating temperature is 70 degrees, horizontal shaft, light load, low contamination levels. The corrected interval starts to take into account the operating conditions and the grease selection you've chosen. So for my example so far, it turns out that the corrected interval is the same as the idealized lubrication interval. However, if we start to increase the temperature, so expect the grease to degrade quicker, so therefore you can see the corrected interval now starts to drop. For every 10 to 15 degrees above 70, you'll see a reduction of about half in the grease life. So it makes quite an impact. Again, contamination levels, if we start to think that they're now moderate rather than low, the corrected lubrication interval starts to drop further. And again, if we went from horizontal to vertical, we drop even lower. So from the original 11,000, we're actually down now to 1,400. Just by changing a few of the inputs. so they can have quite a significant impact. Down at the bottom just here, we've got the grease quantity. So this is how much we recommend relubricating at that 1400 hours. Or if you're looking at an automated lubrication system, we do gives it as a feed rate that you can use. So you'll note here for the lubricator that we've got that's default selected, the LAG D125, we've got a big cross. So what effectively this is saying is that the feed rate that we need is less than what the LAG D125 is going to give us. So actually the automatic lubricator would be pumping in more grease than we actually need. In fact, it says here that we should perhaps consider using a smaller lubricator. If we go to the LAG D60, it now comes up and shows that actually if we set that to 12 months to dispense that full 60 millilitres over that period, then we'll be getting a feed rate in line with the quantity and relubrication interval calculated. As I say, over on the side, there's some support functions. We can go to the dispense rate, and you can see what the dispense rate is for the various different lubricators. We can click on operating conditions, and this is where you can see what impact it will have as the correction factor on the lubrication value. So for example, we go to moderate, you can see that the effects on the relubrication interval halves it. High, it becomes a fifth. Shaft orientation, again, as a factor of 0.5. So you can start to look at this and see how much of an influence some of these have on the calculated relubrication value. Also worth mentioning is the selection charts, and here you can get the overview of the greases available and which operating conditions they're best suited for. And down here, as I mentioned earlier, about how we categorize speeds, loads and temperatures into specific low, medium, high, we can actually equate these now to actual values to help you do that. And that's an algorithm that's used in the dial set when it's looking at what lubricant is suitable based on the operating conditions that you've selected. So that is an overview of the online tools that I wanted to show you. If I just now move back to the slides, just go to the next. I mentioned at the beginning that for a more advanced assessment of rolling element bearings than bearing select, we have Simpro Quick and Simpro Spindle, with Simpro Spindle being aimed more for the machine tool spindle high-speed bearing arrangements. Both of these tools have several modelling capabilities over bearing select. They now consider a single flexible shaft, whereas bearing select was a rigid shaft. You can build in multiple bearings. You're no longer limited to two. Particularly in machine tool spindles, you can have a situation where you have a stack of several bearings at either end of the shaft. And Simpro Quick and Spindle will allow you to put in as many bearings on a shaft as you deem necessary. Programs will also consider the operating bearing clearance effects, including influence of fits and operating temperature. They'll also consider the internal geometry of the bearings, rather than just simply looking at a C/P ratio that bearing select uses. You can build in spring preloads to see what impact this might have on stiffness, bearing load and life, and you can choose from multiple gear types, including spur, helical, bevel, etc. So in addition to the performance valuation parameters offered by bearing select, Simpro Quick and Spindle provide you with the ability to assess bearing displacement and misalignment, bearing internal load distribution, looking at the individual rolling element loads, as well as the load distribution within the contact area. Also allows you to calculate shaft deflection and shaft stresses, although I would say, as a bit of a caveat, that this should not replace any proper FE analysis of your shaft. It is a simplified assessment and based on simplified geometry of the model shaft. It'll provide you with a 3D model animation, so you can start to see if things are operating as you'd expect, moving in the right direction in terms of deflection based on the loads applied. And it will also provide you with a warning system for exceeding limits such as light load, overload, speed limit and lubrication conditions. In the instance of SimPro Spindle, it will also provide you with the ability to review bearing kinematics and also pull up a critical speed map, so you can see if you're close to or have to pass through any natural frequencies that might cause an issue. Of course, this is all, the report is available to be exported as a Word document or a PDF or an HTML file if you need to. One of the other benefits of both SimPro Quick and Spindle are that they are the same tool that the application engineers use. So it'll allow for a faster and easier interaction support with us. You can build up your own model, and if you have any queries or questions over it, then you can simply send us that file and we can open that up and look at it very quickly and review it and go through it. So where to find SimPro Spindle and SimPro Quick? Well, I showed you on the Engineering Tools site. You go to their homepage. Technically, these aren't online, but they are still available to you. You just go to their homepage, and then you will be asked to fill in a form to submit a request for the tool. And then the software support team will create a license and send you instructions on how to begin downloading it. And then it works as a standalone item on your computer. And then finally, I've talked through today about calculation tools associated with bearing and lubrication selection, but please do go and have a look at some of the other tools available on the website. There's ones that can help you with maintenance, condition monitoring, seals. So I'd go and have a look. For example, we've got Housing Select, where you can select your bearing and it will advise what housings are available for it, along with the necessary other components to complete the bearing assembly, seals, locating rings, sleeves. We have Seal Select, which is a seal and accessory selection tool and can help you select the appropriate speedy sleeve, V-ring or radial shaft seal for the dimensions or the operating conditions entered. And finally, we've got Mount and Dismount, which gives you a step-by-step instruction for the most appropriate method for mounting or dismounting the bearing, along with necessary and suitable tooling. I've put in brackets Bearing Assist, as that is a new app that's available that links to Mount and Dismount, and therefore it makes it more accessible for people on the shop floor who might need to get access to that sort of instructional information quite quickly. So again, that's worth looking into. So I'd just like to say again, thank you very much for attending today's webinar. I hope you found it informative and giving you an awareness of the tools available to you to help you with your bearing arrangement design. And Ringo, that brings me to the end.
Okay, thank you, Stephen. I think it was a very interesting and clear presentation. Thank you for that. And we have had some questions in the chat box during the webinar. And I would like to start with the first question. After necessary calculation, can we get any support from SKF to get input related to selection carried out by us?
Yes, I mean, yes, we would recommend if you contact your local SKF representative and talk to them about your requirements, then they can then give you access to the application engineers who can then review through your selection and help you optimize it as necessary if it needs it. So yeah, no, that is something we can support with your selection after you've done your own one to start with.
Okay. Then we have a second question. Is there any chance of result change with reference to old software and new software calculation?
Yes, there is a small chance. I mean, if the bearing geometry and design has changed, and that can have an influence. Some of the algorithms in the background may have been improved. So there is a chance that there could be some slight differences between old and new versions of the software.
Okay, and then we have a third and final question: how to interpret feed rate and relubrication quantity given in result column, because if we calculate feed rate, then it is not matching with lubrication cartridge dial. This was one of the query from our customer while we have submitted report to customer.
Well, the feed rate is simply based on the time calculated for the relubrication interval and the quantity divided by that time. So I'd have to look into that, if I'm honest, a little bit more and just sort of investigate where that difference comes from. So, because I don't believe there should be a difference.
Okay, so maybe you can come back to that later, and we will send an email with some reply.
Yeah, if they could provide us with a little bit more information about the specifics of the feed rate and what they've calculated, then we can have a look into that and see what the situation is there, what that difference is caused by.
Okay. Okay, that was the final question, Stephen. I think that I can thank you on behalf of SKF for joining this webinar. We will have one more webinar left in this full program. That's next Thursday, same time, same place. Then we go into the maintenance products, the bearing life cycle. Which tools do you need or can you use to prevent preliminary bearing failure? We will go into deep about the different tools, about new developments, and how you can improve the mounting and dismounting procedures in your technical department. And at the end of this day, we will send out a small survey to all the people who signed up and attended our webinars the past 3 months. And we would be very happy if you could fill in this survey, only a small survey, a few questions, but it gives us valuable feedback about our webinar program, how we can improve it when we will continue it after the summer. And hopefully we will meet you again then. For now, again, Stephen, thank you very much for your time and your presentation. Hopefully it will help the people to get more out of our online tools. Thank you very much for joining. Stay safe and enjoy the rest of your day. Thank you very much.
Yeah, thank you, everyone.